That's interesting. Somehow this is not connected. Why? Okay, not audible. Cool. Hello, 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 hello. Can you guys hear me now? I think I'm audible now. Let me know if I'm audible. Awesome. Yeah, cool. I had forgotten to connect the mic. So, hi everyone, and welcome to another interview series. So, let me know how did the contest go? How were the questions? And did you guys like the questions? Did you guys did not like the questions? Were they difficult, easy? How was it overall? How did the contest go? I see someone has got a rank of 15. That's good. Let me know how did the contest go? Third one was little easy, but second was tough. Okay. All right. Cool. We'll start with the problems. We'll start solving the problems. Okay. So first of all, we'll start with the first problem. And again, today also will not write any code. I already have the second codes for the second and the third problem. I'll just walk through them. But yeah, we'll just understand, try to understand how to solve the problem, because again, it is expect. Firstly, you should be able to write the code yourself, so that is there. And secondly, again, it will waste a lot of time, right? When we write the code, we debug and all these things takes a lot of time. So we'll not write any code. We'll just will explain. We'll understand how to solve it, and then yeah, I'll walk you through the code if needed. But yeah, that's the idea. Okay, we'll see the second one as well. Don't worry. So you are given an array of size n containing the values in between 1 to n. You are asked to determine the total time taken in order to pick all the array elements from left to right, but there is a condition. You are also given another array time again of size n, where time of element represents the time after which you can pick the element again. For clarity, while moving from left to right, if you once pick an element, then you can pick the element only after time element second. Okay. So, what is the question here? You are asked to determine the total time taken in order to pick all the array elements from left to right, but there is a condition. Okay. So, if you have picked once picked element, then you can again pick element after time second. Okay. It takes 1 second to move from 1 to I plus 1. Okay. There is no extra time needed to pick an element. Okay. Needed to pick an element. So, for example, 1, 2, 3, 3, we have the array as 1, 2, 3, 3. Write the first problem code. Will not write the code. Will look into how to solve it, and you have to write the code yourself. For the second and third problem, again, there is nothing to write the code. I have the codes, but yeah, you can. I'll walk through them maybe, but yeah, you should be able to write the codes yourself, right? We'll explain how to solve the problem, but again, if you cannot write the code, then something is going wrong, right? So you should definitely able to write the code yourself after you understand the logic. So we have 1 2 3 3, and the time is given to us as 1 2 3 4. Okay, so you start at index 1. We start at index 1 and pick error of 1 in one number of time. Okay, now in 1 second you move from 1 to 2 and pick up 2, that is total pick up 2. So for picking up 2, the total time needed is 1 second. So total time equals to 1. And okay, we start at 1, so 1 does not need any time. We do not need any time to pick it up, so it will be 0 here. For this it will be 1 unit of time. Now next, in 1 second you move from 2 to 3 and pick up error 3, that is 3, right? So you pick this up at time equals to 3, at time equals to 2. Total time taken is 2. In next 1 second you move from 3 to 4, and error 4 is and error 4 is 3. So which, okay, you have already, okay, now we can have repeated values. Now as we have already picked 3, we can only pick this 3, we have already at time 2, hence you need to wait for time of error of I second to again pick it. So what is time of error of I? Time of error of 3 is 0 1 2 3, it will be 4. So after 4 seconds, okay, you need to wait for time of error of I second to peak again. Time of error of I equals to time of 3. Time of 3 is 1 2 3. Okay, it is following a 1 based indexing. 1 to 3 is equals to 3, and hence in 1 second you have moved from index 3 to 4 and waited for next 2 seconds, right? So it will take, like, as we have already picked a 3 here, it will take another, it will take total after that 3 more seconds to be able to pick 3 again. So here we move from this 3 to this 3 in 1 second, and we have to wait 2 seconds more, and so we have to wait for that, and finally picked error 4. Now total time we need is, total time taken will be 5. Okay, 6183, its answer should be 35, right? Why 33? Okay, let's take your input and try to understand, right? So if I explain this problem, let me just explain this problem once again, and before we start like doing it for some test case. So what it tells is, you are given an array. Okay, this is not proper. Let me see what is the minimum I can go. Yeah, okay, so let's select this, delete this, and I'll go one more down. Good. Okay, so we are given an array A, right? This A, GFG, please consider test case to clear a doubt. Okay, so this A will contain some elements, right? Like it will contain elements within the range n. So let's say it contains 1 2 3 3 as given in the example. It contains 1 2 3 3. It also contains a times array. Now what is the purpose of this times array? Let's say it is 1 2 3 4 as given in the first test case. The purpose of this times array is, here you see a duplicate is happening, right? So basically your aim is to pick all these elements. You have to pick 1, you have to pick 2, you have to pick 3, and you have to pick 4, and you only move in this direction. It is also given to you, I think, that you only move in one direction. Let's confirm that once. So it takes 1 second to move from index I to I plus 1. So only we move in one direction, and we have to pick all the elements, right? Now there is a constraint, like to move from index I to index I plus 1, we will take 1 second. But there is an additional constraint, that is, here we have a 3, here we pick a 3. Now if we pick a element, let's say we pick a element A of I, to pick a element again, to pick this value again, let's say A of I equals to K, we pick up K right now. To be able to pick up K again, we must wait for times of K amount of time. We must wait for times of K amount of time to be able to pick it up again after we have picked it. For example, here, let's say we picked it at some time. We picked up this 3 at some time. After that, there is again another 3. So it tells that as this 3 has already been picked up, check the value here, not the array element, check the, means the array element, not the index. This element 3 has already been picked up, right? We have already picked up an item of type 3. Let's call these as types, right? Now, as we have picked up 3 already, what is times of 3? Times of 3 is 3. So we must wait for 3 seconds to be able to pick up 3 again. But from this 3 to this 3 will just take 1 second to move, right? So we come to this 3 at in a time of 1 second, and we have to wait for 2 more seconds, because after 3 seconds we'll be able to pick it. So we'll have to wait for 2 more seconds, and then we can pick up this 3 as well. So let's actually dry run for this one once, and then we'll understand better. Okay, so we have 1 2 3 3, and the times array is 1 2 3 4. Okay, so what we'll do is we'll start from here, and as we can move only in one direction, this is important, we can only move in one direction from I to I plus 1, and we have to pick up all the elements. So definitely we have to wait for the element to be available. If something is not available right now, we have to wait for it to be available. Okay, so we'll start from here at 1. Now we pick up 1, and as this is the first time we are picking up, so there is nothing called delay, right? So we'll pick up 1. So the time taken till now is 0 because we are starting here, we are just picking it up. There is no time needed for picking up element. Only time needed is when you wait or when you move. So now you go to 2. When you reach 2, you have taken 1 unit of time. Now at 2, you just pick up 2. So what are the elements that you have picked up? You have picked up 1, you have picked up 2. Okay, now you go ahead. To go ahead, you will need 1 unit of time again. So plus 1. You come to 3. You're coming to 3 for the first time. You haven't picked up 3 yet. So you will pick up 3 and it will not take any time. Now from this 3, you will go to the next 3 in 1 unit of time. Okay, you reach in 1 unit of time, but you see here also maintain the last time when it was picked. So it was picked at this 3 was picked at time equals to, this was picked at time equals to 0, 1, 2. So this was picked at time equals to 0, this was picked at time equals to 1, time equals to 2. So it says that as you already have picked up 3, to pick up 3 again here, you will need to wait for times of 3. That is 1, 2, 3, 4. Times of 3 is 3. You will have to wait for 3 seconds. That is, you picked up 3 at time equals to 2. Next you can pick up 3 at time equals to 5. Right, plus 3 is 5. So you will just have to wait. So at 5 seconds plus 2 seconds you wait. So at 5 seconds you will be able to pick up this 3 and then you reach the end. So you have picked up everything. So the total time taken will be 5 seconds. Yes, the only waiting time will be 2 seconds. But again, we do not really need the waiting time. We just need what was the last time it was picked up and what is the current time that we are at. And that will help us identify whether we should wait or not wait. Okay, so I'll do this test case. 35 for 6618 6618 1131 and the time that is given to us will be 841 5 2 893. I think I've written it correctly. Let me know. So let's write the indices. So the indices will be 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is the array. This is the times array. Okay. Now we'll start. So current time passed is time equals to 0 initially. And yeah, and also we'll maintain what is that last time, what are the elements we have collected and when did we collect it. We'll maintain that here. Okay. We'll start off here. So we can just pick up 6 at time 0. So 6 is picked up at time 0. We'll write it down here. Now we'll go to the 6. When we go to the 6, we have already picked up 6 at time 0. When can, and also 1 unit of time has passed. Current time is 1. We see that we have already picked up 6 last at time equals to 0. When can we pick up 6 again? It is given by this time array. At index 6 we have 8. So we have to wait for, we can next pick up 6 at 8 units of time. So right now only 1 unit has passed. So we have to wait for 7 seconds more. So at time equals to 8, we'll able to pick this 6 up. And the last time when this was picked will become 8. This will become 8. It is picked at 8. Okay. Next we go to the next element 1. And it will take us 1 unit of time. So 1 is picked at time equals to 9. Next we go to 8. It will take us 1 unit of time. And we'll write here 8 is picked at time 10. We'll go next here. Okay. Now we come to 1. We have picked up 1 at time equals to 9. So at time equals to 9, we have picked up 1. So what is the waiting time for 1? The waiting time for 1 is again 8. That is, when is the next time we can pick 1 again? It should be after 8 units of time from 9. So we can pick up it again at 17. It is 17, right? Yes, 17 second. Currently we are at how much? 10 second, 11 second. So we have to wait for the remaining time. So we'll wait till 17 second. So our time will become, let's erase this part. Our time will become now 17 second, and we pick up one, last pick up one at 17 second. Okay, this one is done. Again we come to another one. So last time we picked up at 17 second and current time is 18 second. Current time past is 18 second. When will be the next time we can pick up one? We picked it up at 17 second and waiting time is 8. So 17 plus 8, what will be 17 plus 8? 15, 25. So we'll wait for 25 seconds. We'll wait up to 25 seconds. Okay. At 25 seconds, we have picked up one and we'll report that, okay, the last time we picked up one is 25. We'll go ahead. 3. Did we pick up 3 yet? No. So we'll just take 1 unit of time. 26 and 3 is picked up at time equals to 26. Next we go to 1 again. Now, last time we picked up at time equals to 25. Now, we will need 8 seconds more after 25 seconds to be able to pick up 1 again. What is the current time? Current time is 27. 26 plus 1, 27. But we can pick it up when? 25 plus 8. That is 33, right? So at 33 seconds, we can pick up 1 again. So we pick up 1 at 33 seconds. We wait for the remaining time. And then we go ahead. We come to the end. So the total time taken will be 33. Total time taken will be 33. Make sense? Okay, I'll try run one more test. So A equals to 1551. 15551. And time equals to 80005. Okay. Okay, let's start again. So we'll maintain here what is the time we visit each element. So we'll start at this one and current time is 0. So we can just pick up 1 at time equals to 0. Next we visit 5. Is 5 picked up? No. And time is 1. Because it will take 1 second to move from 1 to 5. Right? So time is 1 right now. 5, we pick it up at 1 second. Now we go to the next 5 and we take 1 second more. So current time is 2 seconds. But we picked up 5 at 1 second. And what is the waiting time for 5? 1, 2, 3, 4, 5. Waiting time of 5 is 5 seconds. That is, it was picked up at 1 second and next you can pick it after 5 seconds. So at 6 seconds, you can pick it up. Current time elapsed is 2 seconds. So you have to wait for the remaining 4 seconds. So wait for the remaining 4 seconds and at 6 seconds, you can pick up 5. So report 5 that you picked up 5 at time equals to 6. You go to 5 again. Okay. What is the time right now? 6 plus 1. You take 1 unit of time to go from, like this 5 was picked up at time equals to 6. Now you take 1 unit more to reach this 5. So 7 seconds is the time now. Okay. You have picked up 5 at 6 seconds, but you have to wait for 5 more seconds, right, to get the another 5. So 6 plus 5 will be 11. But time elapsed is 7. So you have to wait for the remaining 4 units of time. And at 11 seconds, you will be able to pick up this 5. So 5 will be picked up last at 11 seconds. Now you go ahead to 1. And time is 12 seconds right now. Okay. 1. When was last time 1 picked up? At 0. What is the waiting time for 1? 8. So after 8 seconds, 1 will be available again. But we have already covered 12 seconds. Right? So 1 is available to us. We'll just pick up 1 and go ahead. So total time taken will be 12 seconds. So total time taken will be 12 seconds. Make sense? So how do we solve this problem? Pretty simple. How will we solve this problem? We'll just maintain a map, hash map, right? What will this hash map contain? It will contain the value with the last time taken. It was taken. We'll maintain this, right? When was the last time this value was taken? And at every index, at every element a of I, We will check if A of I is already taken. So we'll check if already taken. If yes, so if it is taken, right? If yes, if it is taken, in that case, check when it is available next. Check when it is available next. And when will it be available next? You can get this from the hash map. So let's call the hash map as H. So H of A of I plus the time of A of I, that is the waiting time. So either you have to wait for some time or you will have it available depending on how much time has passed till now. How much time has passed till now? Depending on this, either you'll have to wait or you'll get it immediately. If it is no, that is you have not taken it, you will just immediately take it. Immediately take it, update the hash map and go to index plus 1. Okay, I think it's clear with everyone. Let me know if you have any doubts. But it should be clear now. If it is not clear, just rewatch the video, right? Just rewind and rewatch it. So this should be clear now. Should we write some pseudocode? Do I need to write some pseudocode or is it clear? Is it clear or do I need to write some pseudocode for this? Okay. Can we have a pseudocode? Okay, let's do that. So what we'll take the hash map h equals to hash map. Again, it depends on the language you're using. C++, it will be map or unordered map. Java, it will be hash map. Right, we'll have h equals to hash map and current time equals to 0 initially. Now we'll go like this. For I equals to 0 to n, inside the loop, what we'll do, we'll first check if we have already taken it, right? If h of A of I is there, so it is not equals to, let's say if we can write like this, that if h has the key, h has key A of I, that is it is already taken. In that case, what we'll see is next available time. Next available time will be what? H of A of I, whatever was the last time it was taken, plus the waiting time of A of I, the time array that you are given. So this is when it will next be available. So our time will be equals to what? It will be equals to the max of, if time is greater, it will remain that, or it will be next available, like we'll have to wait for that and update the hash map, right? Else we don't have to do anything. It is the first time we are taking the element, so we don't really have to do anything in this case. Now we just have to update the hash map. So h of A of I equals to time and then time plus plus as we go to the next index. So this should be the code, right? We are just, why are we doing max here? Because let's say our current time elapsed is 12, but we see the next available time for the current element is 8. That means we have already come to time 12 and it was available at time 8. So we already have it available. So we'll just keep that time to be 12. We'll collect it at time equals to 12, right? But let's say time equals to 6 and next available is at time equals to 8. So that means we have come here at time equals to 6, but it is still not available. It will be available at time equals to 8. So we'll have to wait for these 2 seconds. We'll collect at time equals to 8 and move ahead, right? So that's why we have this update. Why is it saying one? Because it is one based indexing. because it is 1 based index, right? See, time of a of I we are doing here. We are doing here time of a of I. Sorry, time of a of I minus 1 it will be. Yeah, time of a of I minus 1. So the array is indexed as 1 based. Like this is treated as 1, 2 like this. So you have to do time of a of I minus 1. Okay. Cool. Let's go to the next problem. Minimum moves. What does the problem say? Okay. You are given two arrays A and B, both of size n. You are allowed to select two integers x and y and add 1 to all the array elements present in between x and y inclusive, right? You can perform this operation on either of the arrays. You are asked to tell the minimum number of moves to make both the arrays same. Okay, two arrays can be same if a of I equals to p of I. All the elements, uh, right? It is zero based indexing, as in this one time equals to 4. Here time equals to 3 means it will be available here. So this array is one based indexed. This array is one based, like this is time equals to 1, time equals to 2, time equals to 3. So you have to take in the time array, you have to take time of array I minus 1. Okay. And if you have any doubts, you can just check the sample case. It says that waiting time for 3 is 3, right? It is telling here waiting time of 3 is 3. So how will it get 3? Because this is index 3, one based. I'm not sure, the test case might be weak, but that's what the question says. That's what the question says. Might be the test case might be wrong. Okay. So you are given A and B of size n. Okay, it was 0 based. Okay. You are given two arrays A and B of size n. You are allowed to select two integers x and y and add 1 to all the array elements present in between x and y inclusive. You can perform this operation on either of the arrays. You are asked to tell the minimum number of moves needed to make both the arrays same. What is the condition for both the array to be same? All the elements has to be equal. For all I from 1 to n, A of I should be equals to B of I. Then both the arrays are same. Basically what it tells you, you are given two arrays A and B. Now what you can do is, you can, in a move, you can select a range of A or select a range of B and add 1 to all the elements in that range. Your aim is to make all the elements equal, all the elements of A and B equal. So what is the minimum number of moves that is needed? So here you have 2, 3, 5 and 1, 2, 4. So in one move you can select x equals to 1 to this much and you can increase them by 1. So it will become 2, 3 and 5. So in one move you can have both of the arrays to be equal, right? Okay. So yeah, that's the idea. Let's understand how to solve this, right? Okay. Before that, let's actually, okay. So you are selecting ranges, right? Let's have some dummy array. So you have two, let's say you have two here, 4, 3, 2, 4, 3, and here you have, let's say 1, 5, 7. In B, you have the corresponding elements as 1, 2, 2, 5, 7, 3, something like this. Okay. What it tells us that in a move, let's say in a move you decide that, hey, let's take A and select this range, right? In a move you can select this range and increase all the elements by 1. So the array becomes 2 plus 1, 3, 4 plus 1, 5, 3 plus 1, 4, 1 plus 1, 2, and these do not change, 5 and 7. So in a move you can change it like this and you can do it with both of them. You can do this change with both of them. Your aim is what? Your aim is to make both the arrays equal. That is A of I for all the elements I. A of I should be equals to B of I. You have to make both the arrays equal. So what is the minimum number of moves needed? Okay. First thing, whenever you have problem like this, whenever you have a problem where you are allowed, like you have two arrays, right? You have two arrays and you are allowed to make update to both the arrays. In that case, what you should do is you should fix one of the arrays. You should fix one of the arrays and just consider the reverse move. That is, what does this mean? Is this equivalent? Like the current move that we have is choose a range from B, L to R and increment them by +1. Can we say this is equivalent to choose the range in A and decrement them by -1? Decrement them by one move or one step? Can we say these two things are the same thing? With respect to the moves, can we say these two things are the same thing? Here, we are increasing L to R by 1. Instead of that, basically, eventually we have to make B equals to A. So the amount of work this does, this will also do the same amount of work. It will just decrement all the values in this range by -1. So we can say they are identical, because anyways, we do not care what the final state of the array is. We do not care what is A of I, what is B of I. We care A of I should be equals to B of I. So if we take certain amount of time, let's say we take a amount of time t, if we do this move, BLR we increased by +1 total time. The same amount of time will remain when we decrement this A, L to R range, right? The same amount of time will remain. So additionally, we can just interchange them. We can interchange these two moves, right? Anyone has any doubts with this? Any doubts with this? Like how can we interchange? Okay. Okay, I think it makes sense. So what we'll do is we'll go to the next move. So essentially what we have done here is, instead of changing the array B, we are saying we have two moves. That is, choose X and Y and make the range A X to Y to +1, or make the range A X to Y by decrease them by -1. Yes, we can select only array A and increment and decrement on that, right? We have these two moves. So whenever you have two arrays and you are allowed to make moves in both of the arrays, fix one of the arrays and make the reverse move in the second array, that will be equivalent. So one of the arrays is fixed, at least one of the work is done. That is, we know what is the final values that we want. We want to make array A into array B, and we have these types of move. X to Y, we can either increment by 1 or we can decrement by 1. Okay, that's the first step. Now can you tell me, let's say I choose the range 0 to, let's write the ranges 0, 1, 2, 3, 4, 5. Can you tell me, if I choose the range 0 to 2 and I decrement them by 1, does it make sense? If I changed, I'm changing on array A. Remember, I'm changing on array A. If I choose the range 0 to 2 and decrement them by 1, does it make sense? Does this move make sense? It makes sense, right? Because we have to decrement all the elements here. So decrementing the entire set by -1, it makes sense. Okay, let's say I choose the range 0 to 3 and then decide to decrement it by -1. Does it make sense? If I choose the range 0 to 3 and then decrease them by -1, does it make sense now? Think carefully. Exactly, it doesn't make sense, because if we make 1 to 0, if we choose this range and reduce 1 to 0, we are essentially increasing our work without any need, right? We have to make 1 to 5, so we should increase 1, not decrease 1. So this doesn't make any sense. And that actually brings us to a very important conclusion. That is, when we'll always choose the ranges only when all the elements will move in the same direction. All the elements has to move in the same direction. That is, either all the elements has to decrease, we can choose that range, or all the elements has to increase, we'll choose that range. We'll not do a cross between them, that is, we'll not take ranges like this 0 to 3 where one has to increase but others has to decrease. We'll not choose these ranges. That is property number 1. So let's call it property number 1, that is, choose ranges that moves in same direction. Okay, so what does it mean? It means that whatever moves we make here, right, our moves will be only of the form, either like it will be us, like we can at best we can do 0 to 2, and can we choose 3 to 4? Does it make sense to move 3 and 4 together? Does it make sense to move 3 and 4 together? Index 3 and index 4. Does it make sense to move index 3 and index 4 together in some direction? Yes, because they both will move in the same direction. 1 will also has to increase, 5 will also has to increase. So we can choose these two together, right? 3, 4. And again, 5 will be alone. So we will not cross between them. Our moves will always be subarrays of this type. Our moves will always be subarrays of this type. Okay, that's conclusion. That's observation 1. Okay, so it doesn't necessarily mean it doesn't mean that we'll always choose 0 to 2 and increment them, or we'll choose 3 and 4 and decrement them, or something like that. It means that if we choose, the best we can choose is 0 to 2 if we want to choose a range, or the best we can choose is 3 to 4. We cannot choose 2 to 4. We have to choose within 3 to 4, some subarray of 3 to 4. Okay, okay, now let's come to the final solution. Okay, let's consider, so we'll process these two things, we'll process all these ranges independently, that is 0 to 2 this range, 3 to 4 this range, and 5 this. All of them has to be processed independently. Although if you see, 5 needs to decrease, 5 needs to decrease from 7 to 3, but we cannot pair 0 to 5 together, because in between we are actually increasing our work, so it is bad to pair 0 to 5 together, right? So we'll have to process each of them independently. Now let's consider only one way, right? Let's consider one of them. Let's take 2, 4, 3 and 1, 2, 2. 2, 4, 3, and their final state should be 1, 2, 2. So we can compute what is the amount of change we need for each index. So for this index we need a change of 1. We need a change of -1 rather. In this index we need a total change of -2. In this index we need a total change of -1. So what we can do here is, always we'll start from the left hand side, right? We'll start from the left hand side of the range. Check. Okay, -1 is there, so will definitely need a move of -1. So add it to the answer. Answer equals to 1. Now go to the next part. In the next we see we need -2. Now in the previous element we have seen -1. That is, it will not be covered by the previous element. It will not be covered by the move of the previous element. We need -2 here, but we have only got -1 till now. So it will not be covered. So we'll add +1 to the answer so that we get -2. We can come down by -2. Now what is the total? What is the total maximum we have got? We have got -2 total. Next we go to -1. Now -2 is greater than -1. So we have covered -1 already. By choosing this range of -1 and doing a -1 operation, we have definitely covered this already. So we do not add to our answer. We do not add to our answer. Let's take the reverse way around, right? This is the positive case. Let's take the negative case, right? So this will have a total value of 2, total moves of 2. Next what we'll do is, let's take this example of 1, 5 and 5, 1, 5 and 5, 7. Okay, we have 1, 5 and we have 5, 7. What is the difference? From 1 to 5 we need 4 plus 4. 5 to 7 we need plus 2. So in the first one, we know that we have to make plus 4 moves. So we'll add plus 4 to our answer. And also we'll maintain that what is the maximum we have, like what is the maximum plus we have done till now. So that is plus 4. Maximum plus we have done till now is plus 4. Next we come to this. Now here we need plus 2. Definitely plus 2 is already covered because on the left hand side we have a maximum of plus 4. So when we did that plus 4, definitely plus 2 also got covered. Okay, so actually it is not the maximum but the previous one. So previous one had a plus 4. Now we come to this one. So previous one, for previous one we had to do plus 1 4 times. In two of those times we just have to select the next one as well and we'll get it covered. So we do not add anything for this. This is already covered. So plus 4 will be there. So total number of moves for this part will be 4 plus 1 plus 1 6. And also for the last one we will also have some moves, but yeah, that will be the idea. So the algorithm will be, what will be the algorithm? First of all, for, okay, let's look into the code directly, right? Let's look into the code directly. Not this one. Okay, so what we have done here, we have taken the answer to be 0 initially. Previous p means what is the previous positive move that we have done. Previous n is what is the previous negative move that we have done. Now we are going through all the elements I equals to 0 to n. First we check if a of I is greater than b of I. If a of I is greater than b of I, that means we have to go for negative moves. We have to decrease a of I. So first of all we see if a of I minus b of I, if it is greater than previous p, that means the move that we need right now, the previous move that we have done, the previous positive move, or actually it should be, it is actually a bit wrong. So by positive I mean the difference is positive. Instead of previous p, let's call it difference of positive, right, or something like that. So this means that the previous positive move that I've done, let's say in the previous means in the before, in the step before or in the index before, the positive move that I've done, if this exceeds that, if the difference exceeds that, that means we need a few more moves for getting it covered. So for that we'll add to our answer. How much we'll add? Ai minus bi minus previous p. Why? Because this much we have already done in the previous index. So in previous p number of steps, we can just take this index as well within the range, and that many times will be reduced, and this difference amount of time we have to do extra. Now we have to update our previous p to ai minus bi, because for the next index again we'll need that, right? So ai minus bi will be previous p, and previous, this is very important, previous n we have to set it to 0, because as the current move is previous p, if we go to the next element and that is the negative move, or that is actually like a of I is less than b of I in that case, so we should make sure that we do not account for this value, we do not account for a previous value. This will be a disjoint part of itself, this will get disjoint, right? So previous n equals to 0. If b of I minus a of I is greater than previous of n, that is, if the other way around, if b is greater than a, in that case we'll see if it is greater than previous of n, the negative move that we have done. If that is true, we'll do 1l into b of I minus a of I minus previous of l, the total difference, and we'll set previous of n to be b of I minus a of I, previous p to be 0. Okay, so let me actually explain this in this way. Okay, think about it like this. You have a histogram. Let's say this is histogram represents the difference values. It will just represent the a of I minus b of I, let's say. So you have this, after this you have this, then this much amount, then you have some negatives. So you have this much, you have this much, and you have this much here. Then you have some positives again. So let's say this, and you have this, something like this. You have so a of I minus b of I, let's assume that we can implement it like a histogram, right? Now see here we are telling that, okay, let's make these many plus ones, now we come to the next index, now here we can just we see that it is greater. It is greater than the previous number of moves that we have made in the same direction, in the positive direction, right? This is calling positive. Let's call this negative. In the positive direction, we have already made these many moves. So what is the delta that is needed? This many number of moves is needed more. So we'll add that. Now we'll go to the next position. Here we will not need any moves, because why? In the previous part we have already made these many moves, right? We have already made these many moves in the previous index. So we could have taken, in all the moves that has been made, we could have just taken these many moves and added it to the range, right? That would have done. Now here, coming here, this is important, very important. Coming here, we have to make these many moves again. You might ask me, hey Soham, we are making here these many moves, right? Why do we need to make additional these many moves here? That is because, let's consider an example, right? Let's consider an example here. We have, let's say, the difference. I'm talking about the difference here. We have 2 and we have 5, we have 2, we have 3. Let's say this is 5, this is 2, this is 3, right? Now in move 1 we take them as a range. So let's write it here, 5, 2, 3. In move 1 we take it as a range and decrement them by 1. So what will it become? 4, 1, 2. In move 2 we again take it as a range and decrement. So it will become 3, 0, 1. Now see, as it is becoming 0, we should not club 3 and 1 together again. We should treat both of them independently. So 3 will be reduced and then 1 will be reduced independently. So again we need these many number of moves, right? You will have to make these many number of moves. Again, same thing for the negative part. For the negative part, let's say in the first move you make these many number of moves, and again this will be completely different from this, right? You have to make sure. Now here you see we need more moves, so you make these moves as well. For the third one, we do not need any moves because we have already made these many moves, right? We do not need this. We can just add it to one of the ranges and it will get done. Is some of the ranges and it will also get completed. So we don't need. Now when we come back here again, we have to treat it differently. We cannot bring whatever was here. Whatever was here, we cannot bring them because this part was disjoint. This part was disjoint. So we cannot tell that, okay, here we completed at this level, we can resume from this level here, because we have not taken this range. We will not take this range, so we cannot take a range like this. We cannot take a range like this, right? So we'll treat this independently again. We'll do these many moves, and after that, this will not need any moves. Does this make sense? Okay, so let's take 3 to 89. Let's take that 3 to 89. Maybe you can give some negative values as well. That will be more sense. Okay. But let's do it in one direction only as of now. So 3 to 89. Sorry. 3 to 89. Let's quickly draw the histogram as well for this, right? How will the histogram look like? 3, 2, after this 18, and somewhere here 9, like this, right? So now think about it. What will you do? In first step, you can take this entire range together and reduce them by 1. So it will become 2, 1, 17, 8. Now you can take this entire range and reduce them by 1. So what will it become? 1, 0, 16, 7. Now you cannot take this entire range and reduce them by 1 because this 0, it has already reached 0. So you should treat both of them independently now. So this 1, you can reduce it in one step to 0. This 16 and 7, you have to treat it independently now. So 16 will be how much? You can, like, again take 7 steps like this. So 16 minus 7 will be 8. So 8, 0 it will become after 7 steps, right? And like this, it will now, this 8 will continue for 8 more steps, right? So if you look into this histogram, first of all, for the first 3 times we are making a move on this. Out of them, in the 2 times, out of these three times, two times we are including this range as well. This range as well we are including. Again, this is also there, it is greater. So this is also we are including two times, but the remaining we are doing independently. We are doing this two times only, right? Then we are making it independent. So the remaining time, that is 18 minus 2, 14, 16 times we are doing it independently. And in this 16 times we are choosing this 9 times, like this 9 comes within it. So total will be this plus this, 16 plus 3. Does this make sense? So similar thing for the reverse as well. Is it making sense? If you guys want, you can give me another example as well. If you want me to try run on another example. 16 includes 9 times. Yes, 16 is like we have to do this 16, right? You have to like do minus 1 16 times. Out of them 9 times, you can just do minus, include this one as well 9 times. So this gets covered under this. So now I think the code will make more sense. If we look into the code now, it will make more sense. We have previous p, previous n. Now we check if the previous basically will maintain the previous, how much moves we made previously in the previous iteration. So if ai minus bi is greater than previous p, so we'll take the difference, 2 to 9, 2 to 19, that difference we are taking, right? Then we are assigning previous p with the updated value, this many moves we have made ai minus bi, and previous n we are resetting because it will be the other way down. We have not made any previous n moves in the previous iteration, so we should treat that separately. Similarly here also the same thing, bi minus ai is greater than previous of n. In that case we'll take the difference, right? This much has been done and now we want this much, so this difference we'll have to be accountable for. So that will come here and we'll reset like previous n and previous p. Okay, cool. Let's go to the last problem then. I hope this makes sense. The code was pretty simple. Like you can do it multiple ways. You can also take an array and treat the negative ones as 0 in one array and treat the positive ones as 0 in one another array, and you can then do it as well like that. So that's another way. And this is another way. Okay. Why previous p is not that? Okay. Why is not that? Okay, let's take an example why previous p is not that. So we'll just take the positive, right? Positives. So let's say we have 2 here, 1 here. Uh, yeah, we have, let's say, 5 here, and actually not 5, rather we have 3 here, we have 5 here, and we have 4 here. So first we'll do 3 moves. Then for this one we left with 2 moves. Now if we make 2 here, if we assign previous p to be 2 here, like previous p to be the difference here, here we'll know that only we have done 2 moves. When we come in this index, we will know that we have only done 2 moves, so we have to do 2 more moves, which would be wrong, right? We have done 5 moves actually. We have done 5 moves actually. So we should maintain, instead of this difference, we should maintain the total number of moves that we have done on this, that is 5. And now when we come here, we know that we have done 5 moves here, so we can just take 4 out of them. So this will not need anything. Make sense? Cool. Let's go to the last problem. Okay, this is done. This is also done. Okay. Sorry, I think that was not done. Okay, we are given n buckets, and all these contain some initial amount of water which is represented by an array amount. We also have the supply of water in certain order. That is, in all the odd turns we will have odd 1 liter of supply, and in all the even turns we'll have 2 liters of supply. We can fill any bucket with either 1 liter or 2 liters of water in the respective turn, or throw the water away as well. You need to find the minimum number of turns to make the quantity of water in all the buckets to be same. Okay, what does it tell? You are given initially each bucket will have some amount of water. What you will do is, in a move, you can either have 1 liter of water or 2 liter of water, and they will come alternatively, right? So in the first move you will have 1 liter of water, in the second move you will have 2 liters of water, then 1 liter, then 2 liter, and like that. What it tells is that you can decide whether to fill a bucket with the water, that is, let's say 1 liter comes, so you can decide any bucket, fill it with 1 liter of water. Or if 2 liters come, you can decide any bucket and fill that with 2 liters of water. Or you can decide to throw away the water as well, right? You do not want to fill any bucket. You have to tell what is the minimum number of turns, needed to make the water for all the buckets equal. All the buckets will have equal amount of water. Okay, for example, 1 to 0. In the first turn, what you can do is, you will have 1 unit of water, so you can fill up this bucket 1 with 1 unit of water, it becomes 2. In the next turn you will have 2 liters of water, so you can fill up this bucket with 2 liters of water, and this will become 2. So all the buckets now have 2 to 2, so in 2 turns you can have all the buckets filled up. Okay, so that is the question. Let's understand how do we solve this. Okay, now let's say, okay, let's first think about it one thing. Let's say there are t turns. Okay, let me take the white color. Let's say we have t turns. Can anyone tell in these t turns how many even moves, how many 1 liter move, how many turns will have 1 liter, how many turns will have 2 liter? Can anyone tell this? In t turns, how many turns will have 1 liter of water, how many turns will have 2 liters of water? Total turns is t, let's say. How many turns will have 1 liter, how many turns will have 2 liters? So 1 liter will be t plus 1 by 2, and 2 liter will be t by 2. Like 1 liter will be 1 extra if it is odd, and 2 liter will be t by 2, right? Okay, we know that if given t turns, we'll have these many 1 liter turns, these many 2 liter turns. Now, okay, now the task that we have is, we have to make all the elements of one array. Again, we have a similar task, right? Not ai equals to bi, but we have to make all ai equals to some target element. Can anyone tell me what can be the optimal value of the target? And the two moves that we have is a of I plus equals to 1 and a of I plus equals to 2. So can anyone tell what will be the optimal, like what will be the optimal target for which will have the minimum turns? Like we can make all the elements equals to that value and we'll need the minimum number of turns. What will be the optimal target values? That is, all the elements will become this value, right? A equals to target. What can be that? Median. Okay. Think about it. We only have plus 1 and plus 2. We do not have negative moves. Negative moves are not there. Only we can increase. So what will be the value? Like what should be the target for which all of them can become equal? Yes. Either it will be max or max plus 1. Because we have plus 1 and plus 2. So either it will be 1 of max or max plus 1. It will either be max or it will be max plus 1. Does it make sense? Why max plus 1? Because again we have plus 2's, right? So it might make sense to actually go to max plus 1. Either we can end at max or we can end at max plus 1 because we have plus 2 moves as well. Okay. Hmm. Okay, so we have these two things cleared out. Let's write them again. Given t turns, we will need t plus 1 by 2 1 liter moves and t by 2 2 liter moves. The second thing is the target that we want to reach for all the array elements will be either equals to the max element or max element plus 1. Right? These are the two. Okay, these two things we already know. Now what can we do? Okay, think about it. Let's say you are given infinite turns. You are given infinite turns. In that case, you can always make them equal. You can always make them equal, right? Basically, you just do plus 1 to each one of them until they reach the maximum. So you can always make them equal, right? Could you explain max again? Sure. You are just doing these two things. In an array, you can just do a of I plus 1 or a of I plus 2. So what can be the value where you can end up so that all of them are equal? So the max element, you can never reduce this, right? You can only increase the array values. So either you can bring all of them to max, right? You can try to bring all of them to max, but as there are plus 2 moves as well, it might happen that it's better to go to max plus 1 instead of max. So you will bring all of them to max plus 1 and you will just take one move to move max to max plus 1, right? Okay, so if you are given infinite number of moves, you can always make them equal. Why? You can just choose each element and increase them by 1 till they reach the maximum. You can always make them equal, right? You can always make them equal with infinite number of moves. With one move or with zero moves, you might not be able to make them equal. If all of them are equal, in that case that is different, but with zero moves you cannot make them equal. How equal? How will you make them equal? So you have 1 liter and 2 liter. Instead of 1 liter 2 liter, just think about them as a of I. You have move, you choose a index and you do a of I plus 1, and you choose a move, you choose a index and you do a of I plus 2. So just discard all the plus 2's. You can always do a of I plus 1, a of I plus 1 like that, and you can make each of the element equal to the max element, right? I'm not saying a of I plus 1 is max. This is the move that you can make. You can just, let's say the array is 1 2 5, so you can just choose one. You can add 1 liter to this, so it will become 2 2 5. After that you can add 1 liter to this, it will become 3 2 5. After that 1 liter like that, or two more times, it will become 5 2 5. Now you take this one, you add 1 liter of water to this, so it will become 5 3 5. Add 1 liter of water, it will become 5 4 5. Add 1 liter of water, it will become 5 5 5. So they become equal. We No, I'm just saying we can always make them equal. We can throw away the 2 liters. It is given in the question. We can always choose to throw away the 2 liters, right? We can throw away the water as well. We can throw away the water as well. It is not said that we have to always take the water and put it in a bucket. We can throw it as well. So in worst case, I'm saying in worst case, we'll definitely take that. But in worst case, we can always take these 1 liter moves and make all of them equal. We can always make them equal, right? Make sense? Given we have infinite supply, let's say if we have infinite moves, we can always make them equal. Why AI plus 2? Please read the question again. You are given, okay, let's read the question again. We have a water supply. Initially, we are given n buckets. We have some water filled, which is represented by the array called amount. The amount will contain how much water the ith bucket has. What we can do here is we have a water supply that will help us with 1 liter of water or 2 liter of water in alternate moves. That is, the first move will give us 1 liter of water, the second move will give us 2 liter of water, 1 liter of water, 2 liter of water, like that. So essentially what we are saying, we are increasing the array values. We are choosing an index and we are increasing it by +1 or we are increasing it by +2 depending on the move. That's why +2. We have 2 liters of water as well. Does it make sense? So we are saying either we can go from AI in a move. If we have 1 liter of water, we have 1 liter of water supply in this move, or we can have 2 liter of water supply in this move. So we can go to AI plus 2. We can add this 2 liter to this bucket, right? So we have these two possible moves. Okay, so if we have infinite moves, we can always make them equal. If we take 0 moves, cannot make them equal. Like if they're already equal, that is different. If all the elements are already equal, that is equal. But with 0 moves, we cannot make them equal, right? But with infinite moves, we can always make them equal. So this actually, so just think about it. Let's say you have X moves, or let's say you can do M moves. You can do M moves. Let's say for M moves, you can make them equal. You can make them equal in M moves, right? Can we also say that for every move, number of moves greater than M moves, we can also make them equal? Again, what we are saying here is that with M moves, we can make them equal. We are doing M moves and we are making them equal. We are saying that. Can we also say if we have greater than N moves, we can always make them equal as well? Why? We can just throw away some of the moves. We can just throw away some of the moves. Similarly, for M moves, we cannot make them equal. Can we say if we take less than M moves, in that case we cannot make them equal? We cannot make them equal. If in M moves we cannot make them equal, in less than M moves definitely we cannot make them equal, right? Otherwise this condition will be violated. That is, less than M moves we are making them equal, but greater M moves we are not able to make them equal. So this condition will be violated. What does this point us to? What does this point us to? It points us to something like this. Let's say you have an array where the indices are the number of moves. Indices are the number of moves. This is an array. Exactly. Let's call it is possible. And the indices are the number of moves, like 0, 1, 2, like this. These many moves, infinity. So we will have false initially. That is, it is not possible. At some time it will become true. And it will remain to be true after this. So in this array, we can do binary search. We can binary search for the answer, for the number of moves, right? We just have to find the first occurrence of true. That is the minimum number of moves needed to make them equal. Does this make sense? Does this make sense? Sure. So we are saying, again, we are saying what? We are saying if m moves, if for m moves, we can make them equal. So we are also saying that for greater than m moves, we can also make them equal. This is what we are saying. Do you agree with this, Shomojit? If for m moves, we are making them equal, we are saying that for greater than m moves also, we are making them equal. We can make them equal. We will just throw away the remaining moves, right? Let's say for 3 moves, we can make them equal. We can make them equal in 5 moves as well. Just throw away 2 moves. Similarly, if for m moves, we cannot make them equal. So less than m moves, also we will not be able to make them equal. Will not be able to make them equal. Otherwise, we'll say, we are basically, if this is not true, we are saying that in 2 moves we are making them equal, but in 3 moves we are not able to make them equal, which is false, because this condition will be violated then. Okay, for greater than m moves, sometimes we can't. We always can. We always can. Why? Let's say we can do it in 3 moves. We can do it in 3 moves. In 5 moves also we can do it. Why? We will just throw away the other 2 moves. We have the opportunity that we can throw away the water that is given to us. We can throw away the water. So we can just throw away for the 2 moves. So we always can. Okay. Now what does this? If we just think about this statement and create an array. Just think about this statement and create an array where m is the index. So we are saying that for index 3, if it is true, for index 4 it will be true, for index 5 it will be true, and it will remain to be true. Similarly, for index 2, if it is false, for index 1 also it will be false, for index 0 also it will be false. Right? Where this true and false means whether we can make them equal or we cannot make them equal. So this will basically answer the question, can we make them equal? Yes, after m always true. So this makes sense, right? Now if we have an array like this, where we have some false, and after that we'll start having true, how can we find the first occurrence of true? How can we find the first occurrence of true? We can do binary search. This is a monotonic array. Instead of false and true, just think about them as 0 to 1. It is a monotonic array. So we can always do binary search and find this first occurrence of true. So we can do binary search on the number of moves. We can binary search on the number of moves. Now once we get, like once we fix, how do we do the binary search? We'll fix the mid. So mid will be the number of moves. We are doing the binary search on number of moves. So mid will be the number of moves. So how many plus 1 move will be there? It will be mid plus 1 by 2. We have already, if there are m moves, m plus 1 by 2 will be plus 1 moves. Plus 2 moves will be how many? Mid by 2. Now we can just check, and also we'll have the number of plus 2 moves or the number of plus 1 moves that we need, right? Because when the difference, when a of I, so we are going to target, we are going to some target minus a of I. When this is odd, we need some plus 1 moves. When this is even, target minus a of I is even, we can just complete them with plus 2 moves. Yes, if plus 2 moves are not sufficient, we can take some plus 1 moves as well, right? So we can figure out how many plus 2 moves, how many plus 1 moves we need, and here we will know how many plus 2 moves, plus 1 moves we have. So we can just check if the number of moves we need and the number of moves we have that satisfies our condition, then we'll return true, otherwise we'll return false, and that we will do the binary search. Okay, take a test case, sure. Let's take the sample case only, or if you have any better case, let me know. So let's take 1 2 4, 1 2 4. 1 2 4. Okay, now let's say we are converting them all to 4, and we want to find the number of moves needed to convert them to 4. How many, like, what will this difference be? 1 minus 4 will be 3. So you need plus 3 here. 2 to 4, you will need plus 2 here. 4 to 4, you will need 0 here. Right? Okay. So that is, here we say that we have a plus 3 and here we have a plus 2. Okay. Now we do binary search. So low equals to 0, high equals to, let's say, 6 or 7, something like that. Let's take. Okay. So what is mid? Mid equals to low plus high by 2, that is 3. Now we are saying that we have 3. What is 3? 3 is the total number of moves. If 3 is the total number of moves, how many 1 liter move we will have? We will have 2 1 liter move. We will have 2 liter move, 1 2 liter move. Right? Now we will check if this is enough. If 2 1 liter moves, 1 2 liter move is enough. Sorry, if mid is 3, yes. If 2 2 liter move, 1 2 liter move is enough. So let's see. Let's say we add plus 3. We have plus 3 here, plus 2 here. We add plus 2 here. So this part is settled. 1 liter move is also, and 2 liter move becomes 0, and 1 liter is 2. So we do plus 1 here, it becomes 1, and we do plus 1 here, it becomes 2. So we still have a difference of 1, right? We still have a difference. We needed to make 3 plus 3, we got plus 1 plus 2. So we still have a difference of 1. So we will tell that with 3 liter, with 3 moves, we cannot make it. Let's take the next mid. So here we'll make what? Low equals to 3. Now low becomes 3, high becomes 6. Now low plus high by 2 will be what? Mid will be equals to 9 by 2, that is 4. With 4, what do we have? We have 2 1 liter moves, 2 2 liter moves, right? Will this be enough? Let's see. We have to make plus 3 here, we have to make plus 2 here. So initially here we have 0 and 0. So we take a 2 liter move and we make it plus 2. So this is satisfied, and number of 2 liter moves left is 1. Now with this 2 liter move, plus, first we make it plus 2. So it will become plus 2 and it will become 0, 2 liter move. Now we have 2 1 liter moves. So sorry, it is 2 liter, it becomes 0. We have 2 1 liter moves. We'll just take one of them and we'll make this plus 1. So 3. So we have plus 3 here, plus 2 here. So that means, and 1 liter we will throw away. This is throw away. So with 4 moves we can make it. With 4 moves we can make it. So we'll set our high to 4 and we see that that is the answer. Like we come to the condition where low is, like, 3 is false, 3 is false and 4 is true. So with 4 we can have the answer. Right? So simple, like you just have to do the binary search. And in the binary search, what do you get? In the binary search, you get the number of 1 liter moves. You get the number of 2 liter moves. And you know how many, like what is the difference that you want to make. Or you can also treat odd and even like this as well. Like you can treat the odd separately, even separately, and then get it done, right? So with the event, first of all, settle the event. How do you settle the event? So event minus equals to like how many 2 liter moves that you have. So 2 liter moves, right? Now if you have 2 liter moves left, you can use that for odd right now, odd elements right now, right? So like that you can do. Okay, so that will be the idea. Does it make sense? And what you can do, yeah, it is very difficult question. Not really. It is like once you understand it is binary search, you can do it. So I'll quickly take you through the code. So it's something like this that first of all, I find the max element, then I can call the calculate for like answer with max element and max element plus one. We'll calculate for both of them, and there in the calculate, what we'll do is we'll find. Actually, this is not a very good way to do. In fact, you can actually try to. Here we are using odd and even concept, but again, you can do it better by just maybe increasing the elements and like sorry, in a brute force way, increasing the elements and seeing if you have enough plus one or plus two moves, right? So that might be a better way. So yeah, that can be there. So again, what you can do, what you could have done here instead of one and two, like I really don't like this way of solving. Rather, what you can do is and because here one problem that we have is we are just using the for the one moves, the odd moves, we are just using the one moves, right? Plus one moves. So that is not really I don't feel like that should be a good way. So instead, what you should use is you should maintain the difference array. You should maintain the difference array, and there first of all settle the plus like even differences by using plus two moves, and then try to settle the odd differences, right? Something like that. So this will become order of n, this part will become order of n, and this will then run a binary search of log n. So log n into order of n will be the total complexity. So yeah, like we are just doing a binary search, we're finding the differences here and doing a binary search, and then figuring out the answer, right? Returning the answer, and here calculate the answer and return it. Yeah. So that will be the idea, but yeah, like I would prefer something doing like this, that maintain this difference array, right? uh, when you do the binary search, maintain this difference array, let's say 2 1 3, something like this. Now here you have some number of plus 2 moves and you have some number of plus 1 moves. Let's say 3 plus 1 2 plus 2 moves and 3 plus 1 move. So you can just go here, first of all tackle the even elements. So 2, it will become 0, and you have taken 1 plus 2 move, 1 3. Now tackle the odd elements one by one. So here we have 1, so you can just take plus 1 move. So just take away, it will become 2, and this will become 0. Next, go to this element. So here you can take a plus 2 move, so take it. It will become 1. Now you take a plus 1 move, it will become 0. So like this. Yes, see the number of one move, so all of them should become 0, right? Exactly. So I can give a pseudocode about for this. Pseudocode will be something like this, that let's call it check. We have the difference array, we have the one moves, we have the two moves, right? So what we can do is, for first of all, go through the even elements. So for I equals to 0 to n, the length, if even, if diff is even, diff of I is even, rather, if diff of I is even, in that case uh, diff of I, what we can do is diff of I will see if we have enough two moves. So here we can check. uh, so number of moves needed, let's find the number of moves, two moves needed. So num moves needed is difference of I by 2. This many number of 2 plus 2 moves is needed. So how many do we have? If the number of 2 moves that we have is greater than equal to the num moves needed, right? Num moves, in that case we'll just do 2 minus equals to the num moves, right? uh, Otherwise we'll set 2 becomes 0, and then we'll take from 1, right? So number of, so diff of I minus num moves, the remaining part we can take away from 1 moves, right? 2 1 moves. So like that we can take away. So that will be kind of the logic. Similarly, for the odd also we'll do the same thing, and finally we'll figure out if we are able to do for everything. Wherever we are not able to satisfy, we'll just return a false, and at the end of this check we can return a true. It's not better. It is a bit hacky, I would say. Again, why is it a bit hacky? Like I'm not sure about the mathematical. Like I just quickly wrote it, but yeah, the hack here is that we are using for two moves. We are using this, right? But for one moves, if you see, for one moves, we are just taking the one moves, right? We are not using the two moves for like plus one moves. And here what we are doing is yeah, if it is so here we are doing required one plus plus actually yes, and plus max amount of I. Oh right, no, actually we are trying to formulate everything is plus 2. Okay, no, this is actually right, this is actually correct. So what we are doing, actually this is better way, right? This is actually better way. Again, that will be a more intuitive way. This will be a better, because here if it is odd, then we are just taking them as plus 1 moves, because that has to be satisfied with plus 1 only. The difference, like let's say it is 3, so you can take a plus 2, but you have to take a plus 1. So that's why 1 plus plus, but required 2 will be max. For every time we'll take max minus 1 by amount by 2, right? That will be the required 2. Then we'll try to satisfy the 2 with both ones and twos, and the ones will has to be satisfied by 1. So that is exactly what we are doing. Why 2 equals to 0? Initially 2 equals to 0, right? Initially 2 equals to 0, but after that we are adding like 1 becomes mid plus 1 by 2, 2 becomes mid by 2, and here we are computing. Okay, so what essentially we are doing here is that, okay, let's say we have a difference of we have the difference to be 3 and 4. So we are saying that for this 3 can be written as 2 plus 1, right? So we'll have to have a plus 1 move here. So plus 1 move will needed will write as 1, and plus 2 move that we can have, like this is needed must, plus 2 move we can write as for this 3 as 1. It is not necessarily we have to do it by plus 2. We can take 2 plus 1 as well and fulfill it, but for this plus 1 move it is important, it is necessary for us to take a plus 1 move only. Okay, so plus 1 for this 4, we tell that plus 2 move is plus 2. So total plus 2 moves needed is 3, total plus 1 move needed is 1, right? So now let's say there is 1 plus 2 move and 3 plus 1 moves. So what we can do is, or 5 plus 1 moves, something like that, 2 and 3, yeah, 2 and 3 plus 1. In that case we can take away 1 plus 2, for plus 2 needed is 3, right? So we can take 2 away from here, 2 away from here, so we'll be left with 1 we can take with 2 plus 1 moves. So 2 plus 1 moves means we are left with 1 plus 1 move, and this becomes 0. Now for plus 1 we also need just one of them, so we'll just take this and we satisfy the answer. So that is what we are doing here, and this is better. And again, you can do it with array as well, that will become a bit more intuitive, but this is a bit better. So this, because this will be order of 1 complexity, right? So yeah, that will be the code. I think this makes sense now. Try this yourself once. Yeah, this is order of 1. So try this yourself, definitely try this yourself, and I think you will have more clarity on what we are doing here. Okay, so yeah, thank you guys for joining, and I'll be seeing you next week. So bye and good night. And definitely like try to write the codes once yourself, that will make things more clearer.